Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Master's Degree Programs, Master of Computer Applications, MCA, New, Semester 2, MCS, 219 Object-Oriented Analysis and Design, Block-1 Object-Oriented Analysis and UML, Unit-1 Introduction to Object-Oriented Modeling, 1.0 Introduction. Object-Oriented Analysis and Design, OAD, is an approach for developing software systems using object-oriented. Software engineering concepts, OAD, is about having lots of options. There is never only one right way to solve a problem. More options may exist. The more options you have, the better chance you will find a good solution to every problem. Requirements are those things which your system must do to work correctly. Object-oriented analysis, OA, is the primary technical step in developing a software system using the object-orient approach. OA is based on a set of basic principles that include modeling the problem domain, representing behavior, and describing functions of the system. In object-oriented design, OD, the model created using OA is transformed into a design model that works as a plan for software development. Object-oriented analysis and design methods emerged in the 1980s and object-oriented analysis methods emerged during the 1990s. In the early stage, object orientation was primarily associated with developing graphical user interfaces, GUIs, and a few other applications. In OAD, a very basic concept followed is one should model software systems as collections of cooperating objects, treating individual objects as instances of a class within a hierarchy of classes. In this unit, we will discuss the basic notions of object orientation, including discussion on principles of object orientation. You will learn the basic constructs of an object-oriented system. Also, we will discuss the basics of the object model with the help of an example. Finally, in this unit, we will discuss the benefits of object orientation and introduce to some OAD tools. 1.1 Objectives. After going through this unit, you should be able to describe basics concepts of object-oriented modeling, explain the principles of object orientation, explain various features of object orientations, including class and objects, links and associations, explain the concept of generalization and inheritance, describe the benefits of whom, and explain any given object models. 1.2 Introduction to Object Orientation. The concept of OAD was introduced during 1980s and early 1990s and multiple OAD approaches were suggested, and the most popular were Object Modeling Technique, OMT, for software modeling and designing. James Rumbach suggested it in 1991. He has suggested three types of models: object, dynamic, and functional model for software modeling. Another approach was Booch methodology of object-oriented analysis and design, which was proposed by Grady. Booch proposed the OAD approach is sequential in nature. The analysis phase establishes the system requirements and performs domain analysis from the customer perspective. Once the analysis phase is complete, the design phase, which is iterative in nature, maps the logic design to the physical design. The prototype is created and tested. It is one of the widely used approaches in object-oriented software engineering. Another popular approach for object-oriented software engineering, which was proposed by Ivar Jacobson 1992. It was the first object-oriented design method that made use of use case diagram in design. The phases included in his approach includes requirement gathering, analysis, design, implementation, and testing. He also introduced interaction diagrams to depict the sequence of operations in real-time and state transition diagrams to depict the change in state of object during execution. They are the pioneers in the field of object-oriented software engineering. We know developing a model for a software system needs to follow well-defined steps. Prior to the system development or transformation, it is essential to have a blueprint for the system. It is similar to having a model design for building a residential society. When we try to understand object-oriented modeling, we may find an entirely new way of thinking about problem analysis and creating a system model. The methodology is about visualizing things using models organized around real-world concepts. Object-oriented models to help understand the problems, communicate with domain experts from a distance, model enterprises, and design the layout of CC computer programs and databases. Object-oriented models are represented using slandered diagrams. A good model is always helpful in communication among project teams and assures architectural soundness. The object modeling technique, OMT, covers aspects of object-oriented analysis and design. OMT provides a very productive and practical way of software development. The best part of object-oriented technology, OT, is that it is not language-dependent. There is no need to consider a final implementation language during object-oriented modeling. Analysis helps you ensure your system works in a real-world context. OT combines structural, control and functional aspects of the system. We will discuss the structural, control and functional aspects in great detail in Blocks 2 and Block 3 of this course. When we talk about a system, it means the complete application project. It is important to note that the increasing complexity of systems increases the importance of modeling techniques. Because of its characteristics, is a suitable modeling technique for handling complex systems. The is basically used for building an application model, which includes the system's implementation details during the system's design. Any system development follows a software development life cycle, which mainly includes analysis, design, and implementation. During object-oriented modeling, identification and organization of application with respect to its domain is performed rather than their final representation in any specific programming language. Once the system's modeling is complete, it can be implemented in any suitable programming language. The approach is an encouraging approach in which software developers have to think about the application domain throughout most of the software engineering life cycle. In this process, the developer is required to identify the inherent processes of the application. First, the developer organizes and understands the system correctly, and then they detail the data structure and functions of the system. Also, it is found that most good design comes from an analysis of bad designs. Therefore, analysis plays a very important role in proper system design. You can solve a big problem by breaking it into many functional pieces and then working on each piece individually. For this, you need to perform a proper analysis of the system. As change is constant, your system should always improve every time you work on it. It is important for any designer developer to make sure that their software does what the customer wants to do. Also, as an expert, you are expected to design the system that must work in the real world, not just when everything goes as you expect it to. When things in the system go wrong, your system must have alternate paths to reach the system's goal. Also, an important point to remember is that customers do not pay you for great code. They pay you for great software. A requirement is usually a single thing, and you can test that thing to make sure that you have actually fulfilled the requirement. When looking into a systems architecture, it is the organizational structure of a system, including its decomposition into parts, their connectivity, interaction mechanism, and the guiding principles and decisions that you use to design a system. Good design will always reduce risk. Therefore, goof analysis and design of the system is a must for its successful implementation and customer satisfaction. Object-oriented modeling and design, it consists of the analysis and design phases, which are related but distinct. The first step of OAD is identifying requirements and developing an object model of the application domain, OA phase. Software specifications are established during analysis. In this phase, using various models, an attempt is made to understand the problem by looking at real-world concepts. The next step is OOD, in which the important construct used is the object. An object is the instance of a class and contains data structure in addition to its behavioral characteristics. Objects can interact with each other to design various applications and programs. Object-oriented modeling is divided into various stages. The of the system passes through the following steps: requirement analysis of system, designing of system, detailed designing with a focus on objects in the system, and implementing the model. Figure 1.1 shows the development process in object-oriented development, model design. Look at the screen. Figure 1.1, Object-Oriented Development Model, System Analysis. At this stage, a problem statement is formulated, and the analyst builds a system model to encourage real-world situations. This phase shows the essential properties associated with the situation. The analysis model is a concise, precise abstraction and agreement on how the desired system must be developed. You can say that here the objective is to provide a model that can be understood and also criticized by any application experts in the area, no matter whether the expert is a programmer or not. All the system requirements and their properties should be defined at this phase. The main objective of this stage is to provide a model that can be understood by any naive user or expert in that area. System design. During this stage, the complete system architecture is designed. System design. Whole system is divided into subsystems based on both the system analysis model and the proposed architecture of the system. Based on the analysis model, the system's architecture is defined and designed in this phase. Also, when the system is big and complex, it is partitioned into various small subsystems based on the analysis model and system architecture. Object design. During this stage, a design model is developed based on the analysis model already developed in the earlier phase of development. The object design decides the data structures and algorithms needed to implement each of the classes in the system. Using the implementation details given in the analysis model, the steps followed in object designing are as follows. Procedures. Operations performed on various classes are identified and finalized. The logic required to implement the procedure gets decided. All the paths for retrieving data are optimized. A list is prepared for all the permitted external interference. Classes and their associated operation are rearranged or adjusted to increase the inheritance properties between classes, and packaging of all associated classes is done in a single module implementation. At this stage, the final implementation of classes and relationships developed during object design takes place using any particular programming language. Implementation of database and hardware implementation, if needed, is done in this phase. The actual implementation must be done using software engineering practice. This helps to develop a flexible and extensible system object modeling technique (OMT) to cover the complete system description. Whole object-oriented modeling is done using three kinds of models: object model, dynamic model, and function model. Object models are used to describe the objects and their relationships with each other in the system. The dynamic model describes the interaction among objects and information flow in the system. A functional model describes the data transformations in the system. All three models are applicable during all the stages of development. These models bear the responsibility of acquiring implementation details of the system development. It is important to note that you cannot describe a system completely until all three modes are appropriately described. In Block 2 of this course, we will discuss these three models in detail. Before we further discuss object-oriented modeling, let us see how object-oriented development differs from structured development of the system. The structured approach is seen as the most direct way of implementing the desired goal. In the structured approach, the main emphasis is on specifying and decomposing system functionality. A structured approach has certain basic problems, such as if the requirements of the system change, then a system based on decomposing functionality may require massive restructuring, and the system gradually becomes unmanageable. In contrast to the structured approach, the basic focus of object-oriented approach is to identify objects from the application domain and then associate procedures, methods around these identified objects. Object-oriented development is an indirect way of system development because, in this approach, a holistic view of the application domain is considered and objects are identified in the related problem domain. A historical view of the application helps in realizing the situations and characteristics of the system. Taking a holistic view of the problem domain, rather than considering the functional requirements of a single problem, give an edge to object-oriented development. Once the objects are created with the needed characteristics, they communicate with each other by message passing during problem-solving. Object modeling. Every object has some attributes and behavior. Some common examples of objects include car, student, banking, book, teacher, employee, etc. We can perform many functions on the object, including its categorization, description, organization of objects, combining and manipulating objects, etc. The object model can be represented graphically with the help of class diagrams and object diagrams. Object modeling will be discussed in Unit 6 of this course. Dynamic modeling. It is concerned with time, states, and transition from one state to another, events that trigger the transition, actions that happened after the event occurred and are instantaneous. The dynamic model will be discussed in Unit 7 of this course, functional modeling. In functional modeling, the information is converted and processed. It represents how the data flow from one operation to another. The complete system is designed with the help of data flow diagrams, DFDs. The DFDs' main elements are entities, data store, processes or operations, file store, and data flow. Functional modeling will be discussed in Unit 8 of this course. 1.3 Basic philosophy of object orientation. There are several characteristics of object-oriented technology. Now, let us discuss the essential characteristics of object-oriented systems. Sharing of structure and behavior. One of the reasons for the popularity of object-oriented techniques is that they encourage sharing at different levels. Inheritance is one of the main advantages of any object-oriented language because it gives scope to share basic code. Inheritance of both data structure and behavior allows common structure, base class, to be used in designing many subclasses based on essential characteristics of the base class and develop new classes with less effort. More broadly, we can say that object-oriented development not only allows information sharing and reuse within an application, but also gives a base for project enhancement in future. As and when there is a need for adding new characteristics to the system, they can be added as an extension of existing basic features. This is done by using inheritance, and that too without major modification in the existing code. But be aware that just by using object orientation, you do not get a license to ensure reusability and enhancement. To ensure reusability and enhancement, you have to have a more general system design. This type of design can be developed if the system is properly studied and features of the proposed system are explored. Emphasis on object structure, not on operation implementation. In object orientation, the major emphasis is given to specifying the characteristics of the objects in a system rather than implementing these characteristics. The uses of an object depend highly on the facts of the application and regular changes during development. As requirements extend, the features supplied by an object are much more stable than the ways in which they are used. Hence, software systems built on object structure are more secure. While developing a system using the object-oriented approach, the main emphasis should be on the essential properties of the objects involved in the system rather than on the procedure structure used for implementation. During this process, what an object is and its role in the system is deeply thought about. Using OOAD, good software systems can be designed. In fact, OOAD provides a way to produce well-designed applications that satisfy both the customer and the programmer. 1.4 Principles of Object Orientation. In OOAD process, O principles are used. These principles add flexibility, maintainability, and extensibility to software. Also, applications of these principles in OOAD provide reusable design. In this section, we will discuss O principles. 1.4.1 Abstraction. Abstraction is one of the very important concepts of object-oriented systems. Abstraction focuses on the essential, inherent aspects of an object of the system. It does not represent the accidental properties of the system. In system development, abstraction helps focus on what an object is supposed to do before deciding how it should be implemented. The use of abstraction protects the freedom to make decisions for as long as possible by avoiding intermediate commitments in problem solving. Most modern languages provide data abstraction. With the abstraction, the ability to use inheritance and apply polymorphism provides additional freedom and capability for system development. When you are using abstraction during analysis, you have to deal with application domain concepts. You do not have to design and make implementation decisions at that point. We can see abstraction in the real world all the time, and we just do not think of it in that specific way. One very common example you may take when you interact using your mobile phones. All you do is open an application and press a button to make a call. Actually, you are performing a simple task. But in reality, a lot of things are happening that you may not know or do not need to know as a used user. That is actually the abstraction, and it is applied as a principle in IGNOU 1.4.2 encapsulation. Encapsulation or information hiding is a principle by which we hide data that we don't want the user to see and show data that we want them to see. It is the feature of separating the external aspects of an object from the internal implementation details of that object. It helps in hiding the actual implementation of characteristics of objects. You can say encapsulation is hiding part of implementation that do internal things, and these hidden parts are not concerned with the outside world. Encapsulation enables you to combine data structure and behavior in a single entity. Encapsulation helps in system enhancement. If there is a need to change the implementation of an object without affecting its external nature, encapsulation is of great help. Encapsulation allows you to group your application into logical parts. You should always try to encapsulate what varies. Encapsulating what varies makes your application more flexible and easier to change. Anytime you see duplicate code, look for a place to encapsulate it. Encapsulation is when you protect the information in your code from being used incorrectly. Also, encapsulation separates your data from the behavior of your system. 1.4.3 Inheritance. Inheritance is taken in the sense of code reuse within object-oriented development. During modeling, we look at the resulting classes and try to group similar classes together so that code reuse can be enforced. Generalization, specialization, and inheritance have a very close association. Generalization is used to refer to the relationship among classes, and inheritance is used for sharing attributes and operations using the generalization relationship. In respect of inheritance, generalization and specialization are two faces of a coin in the sense that if a subclass is seen from a superclass, the subclass is seen as a specialized version of the superclass, and in reverse, a superclass looks like a general form of a subclass. Use inheritance when one object behaves like another rather than just when the is-a relationship applies. During inheritance, a subclass may override a superclass feature by defining that feature with the same name. The overriding features the subclass feature with the same names of superclass features, refines and replaces the overridden feature, the superclass feature. Now let us look at the diagram given in Figure 1.2. In this diagram, circle, triangle, and square classes are inherited from the shape class. This is a case of single inheritance because here, one class inherits from only one class. Look at the screen. Figure 1.3, Multiple Inheritance. 1.4.4 Polymorphism. Polymorphism is closely related to inheritance. When one class inherits from another, then polymorphism allows a subclass to stand in for the superclass. The class hierarchy is the deciding factor in the case of more than one implementation of characteristics. An object-oriented program to calculate the area of different figures would simply call the find_area operation on each figure, whether it is a circle, triangle, or something else. The decision of which procedure to use is made implicitly by each object based on its class. Polymorphism makes maintenance more manageable because the calling code need not be modified when a new class is added. Polymorphism allows your applications to be more flexible and less resistant to change. 1.5 Basic constructs of object orientation. In object-oriented modeling, objects and their characteristics are described. In any system, objects come into existence to play some role. In defining the roles of objects, some features of object orientation are used. In this section, we will discuss these features, which include class and objects, links and association, generalization and inheritance. 1.5.1 Class and objects. A class is a collection of things or concepts that have the same characteristics. Each of these things or concepts is called an object in the next unit of this block. We will discuss that the class is the most fundamental construct within the UML. Classes define the basic words of the system being modeled. Using a set of classes as the core vocabulary of a software project tends to greatly facilitate understanding and agreement about the meanings of terms and other characteristics of the objects in the system. Classes can serve as the foundation for data modeling. Now, let us see how the characteristics that classes share are captured as attributes and operations. These terms are defined as follows. Attributes are named slots for data values that belong to the class. The different objects of a given class typically have at least some differences in the values of their attributes. Operations represent services that an object can request to affect the behavior of the object or the system itself. In Units 2 to 5 of this block, we will cover the standard UML notation for whom in detail. Here, we will mention about the standard notation of class. The notation for a class is a box with 3 sections. The top section contains the name of the class in boldface type, the middle section contains the attributes that belong to the class, and the bottom section contains the class's operations. The naming convention for classes is as follows. Class names are simple nouns or noun phrases. Attribute names in a class are simple nouns or noun phrases. The first word is not capitalized, but subsequent words may be capitalized. Operation names are simple verbs. As with attributes, the first word is not capitalized and subsequent words may be capitalized. Objects. The notation for an object is the same in basic form as that for a class. There are 3 differences between the notations, which are within the top section of the class box. The name of the class to which the object belongs appears after a colon. The object may have a name, which appears before the colon, or it may be anonymous, in which case nothing appears before the colon. The contents of the top compartment are underlined for an object. Each attribute defined for the given class has a specific value for each object that belongs to that class. Everything that the software object knows, state, and can do, behavior, is expressed by the variables and the methods within that object. In other words, all the objects share states and behavior. Let us say that a software object that models your real-world bicycle would have variables indicating the bicycle's current state. Its speed is 20 miles per hour, its current gear is the 3rd gear, etc. Communication by message passing. You will agree that a single object alone is generally not very useful. Objects usually appear as a component of a larger program or a system. Through the interaction of these objects, the functionality of systems is achieved. Software objects interact and communicate with each other by message passing to each other. When object X wants object Y to perform one of the methods of object Y, object X sends a message to object Y. Message passing provides 2 significant benefits. An object's characteristics are expressed through its methods, so message passing supports all possible interactions between objects. It closes the gap between objects. Objects do not need to be in the same process or even on the same machine to send and receive messages back and forth to each other. Table 1.1 Difference between objects and classes. Object class. Object is considered as a physical entity. Class is defined as an entity that exists logically. Object is any number of objects can be created for a class. Class is declared once. Instance of a class is an object. Class is used to group similar objects. 1.5.2 Links and association. Links and associations are the basic means to establish relationships among objects and classes of the system. The next subsection will discuss links and associations used to represent relationships. General concepts. A link is a physical or conceptual connection between objects. For example, a student named Shrikant study in IGNOU. Mathematically, you can define a link as a tuple that is an ordered list of objects. Further, a link is also defined as an instance of an association. In other words, you can say that an association is a group of links with a common structure and meanings, for example, a student studying in a university. All the links in an association connect objects from the same classes. A link is used to show a relationship between two or more objects. Association and classes are similar as classes describe objects and association describes links. Note that every association has roles. For example, in Figure 1.8, two classes, student and university, have their defined roles. Here you can also see that binary association has two roles, one from each class. Associations may be binary, ternary, or have higher order. In exercise, the vast majority of associations are binary or ternary associations. But a ternary association is formed compulsion. It cannot be converted into a binary association. If a ternary association is decomposed into another association, some information will be lost. In Figure 1.9 you can see a ternary association. Multiplicity. Multiplicity in an association specifies how many objects participate in a relationship. Multiplicity decides the number of related objects. Multiplicity is generally explained as one or many, but generally, it is a subset of the non-negative integers. Table 1.2 Multiplicity indicators. In associations, general movement is in both the directions of the relationships, but if you want to be specific in any particular direction, you have to mark it with an arrow. Aggregation. Aggregation is a special form of association which models the part whole or a part of or has a relationship as an aggregate, the whole and parts. The is a relationship refers to inheritance and has a relationship refers to aggregation or composition. The most considerable property of aggregation is transitivity. If X is part of Y and Y is part of Z, then X is part of Z. Aggregation is seen as a relationship in which an assembly class is related to a component class. In this component, objects do not have separate existence and depend on composite objects. As you can see in Figure 1.11, exam schedule does not have a separate existence. 1.5.3 Generalization and Inheritance. This section will discuss the concepts of generalization, inheritance, and their uses. IGNOU. Generalization and inheritance are powerful abstractions for sharing the structure and or behavior of one or more classes. Generalization is the relationship between a class, and it defines a hierarchy of abstraction in which subclass, one or more, inherit from one or more superclasses. Generalization and inheritance are transitive across a subjective number of levels in the hierarchy. Generalization is a kind of relationship. For example, saving account is a kind of account, PG student is a kind of student, etc. The notation for generalization is a triangle connecting a superclass to its subclass. A line connects the superclass to the top of the triangle. Lines connect the subclass to a horizontal bar attached to the base of the triangle. Generalization is a very useful construct for both abstract modeling and implementation. 1.6 Identifying classes. In object-oriented modeling, system understanding and on the basis of that, identification of classes is one of the key activity. Establishing relationship among different classes in the system are the first and foremost activity. General practice to identify the classes in SysMen includes textual analysis, when you look for the nouns and verbs in your use case to figure out classes, and related methods is called textual analysis. When you have a good use case, Complete textual analysis is a quick and easy way to figure out the classes in your system. You have to just think about how the classes you do have can support the behavior your use case describes. Nouns are candidate classes in the system. Knowledge of problem domain is essential to do proper textual analysis. For finding the classes which could be representative of the problem domain and are useful in your problem solving, step -1, find the nouns. To find the nouns, you have to read through the problem statement and the associated documentation and highlight the nouns. Nouns you identify in the text or conversation with the client generally translate into classes or objects, attributes, or attribute values. The verbs you identify in the analysis often reveal operations or associations. While interaction with the client user, you should ask questions related to the system with respect to the problem domain. Here it is expected that the client with whom you are interacting has a deep understanding of the problem domain. Step -2. Evaluate the nouns to find classes. As an analyst, you should ask questions to evaluate nouns to find classes. 1. Is the term identified actually needed within the scope of the project or not? 2. If needed, then does this noun qualify as a problem domain resource? 3. If answer to point to above is yes, then think of an appropriate class name for the domain resource to which this noun is referring. 4. Otherwise, find whether this noun is an example of a class, for example, an object, an instance of a class. 5. Otherwise, decide whether the noun is an attribute of a class. 6. Otherwise, decide whether the noun is an example of an attribute. Step 3. Define the purpose. You need to have a proper description about why the class is a required resource of the problem domain. 1.6.1 An object model. Here, we have a simple object model of a university system with respect to different levels of courses offered by the university. As you can see in figure 1.13, which shows the basic classes of this system, this diagram covers different levels of students in the hierarchy. Similarly, for other classes, such as administration and faculty, hierarchy level can be drawn to give a broader view of whole system. Look at the screen, figure 1.13, object model for university system. 1.7 Benefits of object orientation, O, modeling. There are several advantages and benefits of object-oriented modeling. Reuse and emphasis on quality are the major highlights of OOM. OOM provides resistance to change, encapsulation and abstraction, etc. Due to its very nature, all these features add to the system's development, faster development. Increased quality, easier maintenance, reuse of software and designs, frameworks, reduced development risks for complex systems integration. The conceptual structure of object orientation helps in providing an abstraction mechanisms for modeling, which includes classes, objects, inheritance, association. 1.8 Introduction to Object-Oriented Analysis Design Tools. Unified Modeling Language, UML, is a well-accepted language for OAD. It is used for visualizing, specifying, constructing, and final documentation. The basic building blocks of UML used for OAD are things, relationships, and diagrams. Basically, the unified modeling language focuses on the concepts of BOOT, OMT, and Object-Oriented Software Engineering, OSE. The result of these concepts is a single, common, and widely usable modeling language for users of these and other methods. The unified modeling language also promotes the concept of what can be done with existing methods. Many modern applications are being developed based on object-oriented principles such as classes, methods, and inheritance. For making and representing these features of the systems to be developed, some tools are used. These tools support UML features and building blocks. Object modeling. Case tools support object-oriented modeling notations and methodologies, and they also generate parts of object-oriented applications. Many of these object modeling case tools also support relational databases by performing arts of logic and, in some cases, physical database modeling and design, including schema generation and reverse engineering of RDBMS tables and other elements. Many object-oriented case tools are available to address new languages such as Java. Here, we have tried to give a list collected from many sites and individual searches for UML modeling tools. Since UML is a fast-growing engineering, this list may keep on changing all the time. To draw UML diagrams, many tools are available. You may draw UML diagrams using simple drawing tools of MS Words or Paint software. You may also draw UML diagrams using specialized software tools designed for this purpose. Here is the description of some tools software which may be used for UML diagrams. StarUML, https://staruml.io. It is an open source software to develop a flexible, extensible, featureful, and freely available UML platform. This platform is compatible with UML 2.x standard metamodel. You can draw different UML diagrams: class, object, use case, component, deployment, composite structure, sequence, communication, state chart, activity, timing, interaction overflow, information flow, and profile diagram using this tool. StarUML is a multilingual project, so any programming languages can be used to develop StarUML. For examples, C, Java, Visual Basic, Delphi, JScript, VBScript, C#, and VB.NET, etc. The key features of StarUML include the followings: multi-platform support, macOS, Windows and Linux, UML 2.x standard compliant, entity relationship diagram, ERD, data flow diagram, DFD, flowchart diagram, open APIs, various third-party extensions, BAML, https://www.baml.fr. It is UMKL diagram designer software. It runs under Windows, Linux and Mac OS X operating systems. It can be used for the automatic generation of code from the UML class diagrams and rebuild them from existing source code using the languages C, Java, PHP and MySQL. It can also generate code for Python and IDL. It runs under Linux, Mac OS X and Windows. It is extensible, and the external tools, Visual Paradigm, https://www.visual-paradigm.com. It is a UML case tool supporting UML2. It is a powerful visual modeling tool that helps you to build and manage your diagrams and model elements. It has a rich set of diagramming tools to create diagrams quickly and smoothly. ArgoUML, https://argoon.n.softonic.com. It is an open-source UML modeling tool which includes support for all standard UML diagrams, including state chart, activity diagrams, class diagrams, use case diagrams, collaboration designs, deployment, and sequence diagrams, among others. It supports a range of UML 1.4 diagrams, which includes state chart, activity sketches, class diagrams, use case diagrams, collaboration designs, deployment, and sequence diagrams, among others. MagicDraw UML, https://www.magicdraw.com. This tool has full support for all UML diagrams. It fully supports UML 2.5.1, including class, use case, communication, sequence, state, activity, implementation, package, component, composite structure, deployment, diagrams, and UML metamodel. MagicDraw's reverse engineering helps to get UML models from Java, C#, Corba IDL, EJB 2.0, DDL, CIL, MSIL, WSDL, and XML schema source code. Rational Rows. Rational Rows is an object-oriented unified modeling language (UML) software design tool developed for visual modeling and component construction of enterprise-level software applications. ROS is equal to Rational Object-Oriented Software Engineering, Visio Enterprise, https://microsoft.fandom.com/wiki/Microsoft_Visio right parenthesis. Microsoft Visio is an enterprise class software. It contains a UML suite that can build UML diagrams within Visio. Currently, Visio is part of the Office 365 suite. 1.9 Summary. In this unit, we have discussed the basic philosophy of object orientation and the need for object-oriented modeling. Also, object-oriented principles are explained in this unit. This unit discussed the concepts of abstraction, encapsulation, inheritance, and polymorphism. They are the basic constructs of object orientation which makes it possible to develop systems in such a way that the system is flexible and open for reusability. Basic constructs of object orientation such as class, object, links and association and generalization are explained in this unit. Also, we saw in this unit that how inheritance, generalization, specialization, and associations are represented. The reuse and quality of applications are mentioned as benefits of UML. In the last section, some tools which helps in UML diagrams designs are mentioned. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.